Welcome. Today I would like to discuss the topic of X-ray images with you in more detail. This also includes the inclination of the thigh and measurement differences between the leg axis and the thigh axis. Let's start with measuring the leg length. The leg length is measured from the highest point of the femoral head to the plateau of the shin bone. This means that in the normal leg length measurement, the length of the foot is not included, but only the bony length of the thigh plus the joint space plus the bony length of the shin bone. You need to know this because it can be particularly relevant when calculating proportions. For example, if you want to compare the leg length with the length of the upper body or the length of the arm in terms of the wingspan. Let's now look at the leg length now, but at the leg axis. So we take the center of the femoral head and connect it to the center of the tibial plateau. The tibial plateau is an area of the ankle joint. When connecting this line with a normal leg axis, you inevitably pass the knee joint. Now it is important whether you cut the knee joint in the middle, or whether the knee joint is positioned slightly inwards or slightly outwards. This is then referred to as a deviation from the leg axis. First, I mark the intersection point of the leg axis with the knee joint. In this case, the leg axis is in the middle of all joints, which is an ideal case and optimal for load distribution. Then I mark the outer limits of the knee joint. If the knee joint is displaced outwards in relation to the leg axis, this is referred to as an O-leg. 15 to 20% of men have an O-leg deviation. If the knee deviates inwards, this is referred to as an X-leg. 10 to 15% of women have a tendency towards an X-leg deviation. These types of axis deviations from the neutral axis are relevant for the choice of extension and the extension distance itself. Because of the inclination of the thigh to the straight leg axis, the knee joint always shifts inwards during extension. Let us now take a closer look at the individual areas of the thigh on the opposite side. We have the femoral head, which forms the part of the thigh in the hip joint, and we have the femoral neck as a connection to the femoral shaft. In the shaft area, you can see a relatively X-ray dense structure on the sides with a relatively dull gray color in the middle. This is because the thigh itself is a tube. This is why it is also called a tubular bone. The middle is simply filled with a spongy structure. In an X-ray, however, all layers are superimposed so that the sides of the tube appear very dense and the middle is correspondingly less X-ray dense. The nail itself is inserted via the upper end of this tube without touching any joint structures. This means that with a so-called antegrade insertion, that means insertion via the hip area, neither the hip joint nor the knee joint is touched. The tube must be prepared for the size of the nail before it is inserted. And of course, the bone must be severed before the nail is inserted. If we look again at the leg axis and the thigh axis, we can see that the thigh has a certain inclination to the actual leg axis. The lower leg and the shin bone run directly in line with the leg axis. The thigh slopes away from the leg axis. The angle between the thigh and the leg axis is determined by the so-called offset. The offset depends on the length of the femoral neck and its angle. The length of the femoral neck is on average between 4 and 6 centimeters. The angle between the femur and the leg axis is normally 5 to 8 degrees. In this case, the angle is 8.08 degrees. Here, too, the offset is determined by the length of the femoral neck. If we now want to use this number of degrees to calculate the lengthening of the thigh, and thus the real increase in size along the leg axis, we can do so using normal trigonometry if we know the angle. It is often postulated that the deviation of the thigh bone from the leg axis results in a large loss in real length. As soon as we know the angle between these two structures, this can be calculated without any problem. We then see that despite the deviation of the thigh from the leg axis, there is only a relatively small reduction in real lengthening. Even with an extension of 10 centimeters along the thigh axis, this is a real increase in size of around 9.9 centimeters. The loss of real length when the thigh is lengthened is therefore on a fairly small scale.